All right, so we're going to continue looking at complex numbers. We did adding and subtracting yesterday, and today we're going to do multiplying and dividing to start off. Okay, last thing we ended with yesterday was this definition. Okay, and I said we define I to be the square root of -1. Okay, I can't prove that to you. I can't tell you why that's true. I can't explain anything more than what I've written right there. It's a definition. It's kind of like if you asked me to explain why parallel lines don't cross. Well, they just don't. That's the definition. Two lines that never cross, we call them parallel. All right? So this is kind of a building block. It's a definition. And we're going to use it to figure out other things like that. Okay, I think we might have gone through this already yesterday, but does anybody remember what I squared is equal to? -1. Okay, when you think of I squared, okay, you could think of it as I times I, and we define I to be the square root of -1. Right, so it's like writing square root of -1 times square root of -1, which if you just multiply the same thing twice, you can just write it like this. It's the square root of -1 squared. Well, if you square and square root, those two things cancel out. And you just get -1. Okay, that's important. Anytime you have a problem that has an I squared in it, you always need to change it to a -1. If there's any multiple choice answer on the test that has an I squared in it, it's wrong. It's not simplified. Okay, so if you're going through the test and you get stuck and you got to take a guess, you're not sure which one to pick, don't ever pick an answer that has I squared in it. It's not simplified. That's what I just said. So don't ever leave I squared in the final answer. Okay, any question on that? Just the fact that I squared equals -1. All right, so as we go through, especially with multiplication and division, I squared comes up a lot. You never see I squared when you add and subtract. Okay, it doesn't happen. Okay, but when we multiply and divide, you will. All right, so how do we multiply two complex numbers? Well, pretend that those are your complex numbers. Okay? A and B, they would be numbers, okay, in a real problem, and so would C and D. Well, the way you multiply them, you've probably seen this idea before. Maybe you've seen it with something like this. Multiplying those two things together. Yep, that's exactly. Some people have maybe learned it as FOIL. You multiply first, outer, inner, and last. Or you might have learned it as double distributive. Take the A and distribute it to both. And then take the other term and distribute it to both. But either way, it's just like what you did in Algebra 1 when you talked about foiling or distributing or factoring. Okay, how many people learned it as FOIL? Heard that before? Yeah, and that'll work fine here. The only time, sometimes teachers don't show it as FOIL, because if you have something like this, you can't use FOIL on that. FOIL only works if you have two things times two things, which is all we'll ever have today, two things times two things. If you've got three things times two things, well, now you just have to understand the idea of distributing everything here to everything here. Okay? But as I said, we're always going to just have 2 and 2. You'll never have 3. Okay, and when you multiply your first number, in each set of parentheses is always going to be the real part. Your second number will always be the imaginary part. And your final answer should be written just like that. Real part plus or minus imaginary part. All right, so let's see if we can multiply this together. Okay, remember what I said about I squared. If that happens to come up, how we handle that. Okay, Ryan, what would I multiply first here? Yep, so that, in this case, I'd multiply what times what? So we got 2 times 1. First time through, I'll write it all out. So we got 2 times 1. Okay. Carlos, what would come next?
2 times I.
One more time?
2 times I, power 2.
Close, you forgot one thing. Something that goes with the I.
Negative.
That's a negative. Yep, that negative. Think of that negative and that I attached. Okay, the sign before it goes with it. So we have a positive times a negative. That's a negative 2 times I. Okay, next one, Colton.
I
Yep.
plus I.
So would you multiply I by here to get what you said?
1.
I times 1. Okay, and now the last part, we have I times negative I. Catherine, what's positive times a negative?
A negative.
Negative. And what's I times I?
Is this where we negative 1?
You know what? Don't even try to simplify it yet. Just think of it like if I said, what's x times x?
Oh, I
Or
squared.
it's just I squared. Okay, whatever that comes out to, we'll deal with that in a second. So positive times negative, that's a negative. I times I, negative I squared. Okay, let's simplify what we can. So we got 2 minus 2i plus 1i. Now we have minus I squared. But I want to change I squared to what we know that's already equal to. Okay, Helene, what did we just say I squared equals?
Negative 1.
Negative 1. Okay. Any question why I have a negative in front of the 1 or another negative in front of that? Yep.
Because you were subtracting the I squared and then the I squared turned into negative.
Yeah, I had subtraction right here, and then I squared is negative 1. Yep, we're going to change that to addition now. So we get 2. Let's combine what we have here. Negative 2i plus 1. That's negative I. And then minus 1. It's plus 1. And now your last step is to combine positive 2 with positive 1. And Zach, what does that give me? 3. Minus I. That's our answer. Anytime the coefficient of I is a 1, you don't have to write it, like it is in this case. If you want to put in minus 1i, that's okay too. Okay. Any question on that? All right, let's try one more, and then we'll move on to division. Okay, 8 plus I times 3 plus I. Okay, why don't you try it on your own? Okay, if you get stuck, try to remember FOIL. Okay, that's the pattern to multiply everything together. Anytime you get an I squared, change that to a negative 1. All right, so as I went around, it seems like most people got it, so let's do it, but combine some steps as we go. So we got 8 times 3 is 24. You get plus 8i plus 3i, which is how much? Plus 11i. And then lastly, you get I times I, which is I squared, which turns into negative 1. Try to make my i's and 1's look different. Okay, some people left this as a final answer. Okay, if that was a multiple choice question, I might leave that as a final answer too. But it's not done. Combine the 24 with the minus 1. Okay, it's a 23 plus 11i. Okay, any questions on that? Okay, so you've got add, you've got subtract, you've got multiply. And the last thing is divide. Okay, before we can do division, I have to show you what a conjugate is. Right, so suppose we have a complex number. I'm just going to represent it as z. And that complex number is equal to its a plus bi. Okay, a would be a number, b would be a number. Well, when you take and put this bar over the letter, anyone ever seen that before? With complex numbers?
Absolute.
When you put the vertical bars on each side, that's your absolute value.
I know that's repeating.
We also use that same bar to represent something repeating, so this is a little different. In this case, putting a bar above a letter
Use imaginary.
means it's a conjugate. It means it's called a conjugate. And the way you pronounce that is z bar. That's it. Okay, so z bar, they're conjugates of each other.
Who's Z-bar?
Okay. Anybody know what a conjugate is, though? Okay, we know that this symbol means conjugate, but what's conjugate? Okay. All that a conjugate is you take the imaginary part and change the sign of it.
How would we do that?
So if you had a complex number like 2 plus 3i, the conjugate is 2 minus 3i.
Okay.
You just change the sign of the imaginary part. We're going to go through a few other examples, just to practice finding conjugates. Okay, so to find the conjugate of a complex number, negate the imaginary part. Okay, negate is just a short way of saying change the sign of. So in other words, if it's negative, you make it positive. If it's positive, you make it negative. Just change the sign of it. Let's try a few examples, see if that makes sense. So suppose we had the complex number 3 plus 4i. What would the conjugate of 3 plus 4i be? 3 minus 4i. Yeah. Okay, suppose you had negative 8 minus 2i.
Negative 8 plus 2.
Yeah, negative 8 plus 2i. All you're doing is changing the sign of the imaginary part. 5i. Negative 5i. Okay. There's no real part here. If you wanted to put it in, you could think of it as 0 plus 5i. The conjugate is 0 minus 5i. But if it's 0, we don't normally write it. Yeah.
So instead of writing negate, I know what I'm talking about when I reread my notes, like, what can I say, change the sign?
Yep, negate means change the sign of. How about 3? 3. Why didn't you make it negative?
No, it's imaginary part.
Right, you're negating the sign of the imaginary part. There is no imaginary part here. Think of it as 3 plus 0i. The conjugate is 3 minus 0i. Well, plus 0 minus 0, same thing. It doesn't change. Okay, so any question on what a conjugate is, or if I give you a number, how you find its conjugate? On the test, I'm not going to give you a number and ask you to find the conjugate. What we're going to use the conjugate for is it when we do division. Okay. So you have to be able to know, you have to be able to find a conjugate, but only for the purpose of doing division, which I'll get to in a second. Okay. Next thing I want to see what happens when we multiply those two together. Z times its conjugate. Okay, so what's the conjugate here?
3 plus 4i.
3 plus 4i. So we're going to take z, 3 minus 4i, times its conjugate, 3 plus 4i. Just by looking at it, I already know the answer is 25. I don't have to do it out. Okay, let's do it out, see what happens, and then see if we can figure out a shortcut to doing it in our head. All right, so first thing we do is 3 times 3, which gives me 9. What's 3 times 4i?
12i.
12i. What's 3 times negative 4i?
Negative 12i.
Okay. And then the last part, we have a negative times a positive. So that's a negative. 4 times 4 gives me 16. And what about I times I?
Squared.
I squared. What happens when you start to combine like terms there?
You can change the negative 16 to positive 16.
Okay, yep, we can do that because this is really 16 times I squared, which is 16 times negative 1. So you're subtracting a negative. That will become a positive.
And then the i's cancel out.
So positive 12i, negative 12i, that's gone. And if you want to see what JC did one step at a time, change I squared to negative 1. Multiply 16 times negative 1. It's negative 16. And we're subtracting a negative number. So it becomes addition. 9 plus 16 is 25. Anybody see a shortcut for how to do that? Because you're going to get something that cancels out each time. So that part you don't even need to worry about. It's really just the outer. I'm sorry, the first and the last.
Does it subtract and add? Like the signs are flipped, so you're going to get plus.
You're always going to get a plus in here, yeah? It's always going to be something plus something. How do you get this first number? How do we get the 9? We just square the 3. How do we get plus, it would be plus 16. How do you get a 16? You just square the 4. Okay? So all you have to do is look at that number, square it, look at the other number, square it, and then add them up. Okay, so if we did this one quick, the only reason this trick works is because these are conjugates. If they weren't, you got to do it out the old way. But if you square 5, what do you get? 25. Square just the number. Square the 4. 16. What's that add up to? 41. It's a quick trick to multiply conjugates in your head. If you did the 5 times positive 4i and 5 times negative 4i, that's just going to cancel out. And then the last part, negative 4i times positive 4i, that's a negative 16i squared, just like we had before. That'll turn into a positive 16 plus a positive 5 times 5. So 25 plus 16.
So it's only the first and the last?
Yeah, it's just the number. Or you could think of it as multiplying the first and the last. I just think of it as take that and square it, take that and square it, and add them up. Now some people say, well, you have to square the negative. Well, it doesn't matter. If you square the negative, it goes away. Negative squared is positive. Let's try one more like that. Let's do 6 plus 3i times 6 minus 3i. What's the answer?
42.
40 what?
2.
45, yeah. Square the 6, you get 36. Square the 3, you get 9. 36 plus 9, 45. If you don't want to use the shortcut, you don't have to, but it does save, it saves a little bit of time. Only works if you're multiplying conjugates. Okay, so here's the shortcut. The formula to multiply conjugates together. Take the first number, square it. Take the second number, square it, add them up. Okay, notice the kind of answers you got. 25, 41, 45. What's missing from all those answers? I. There is no imaginary part. Okay, when you multiply conjugates together, that's the whole point. You cancel out all the imaginary parts. Okay, question on that? All right, so we're going to use that idea to do division. So when we divide, there's a lot of things we know we can't do. We can't divide by 0. Okay? You can't leave square roots in the bottom of a fraction. Okay, we did that a lot back in chapter 2. Well, you also can't leave i's in the bottom of a fraction. So we need a way to cancel out I. Well, we have that, the conjugate. We know that if we multiply conjugates together, we can make all the i's disappear. So to divide two complex numbers, this is what you do. You multiply the top and the bottom by the conjugate of what's in the bottom. So to do division, we really do multiplication. Question?
Can you re-say what you just said?
Yeah. To divide two complex numbers, multiply the top and the bottom by the conjugate of what's in the bottom.
Just to get rid of the I.
Okay.
And what that's going to do is it's going to get rid of all the i's in the bottom. That's the goal.
When I read it, it just didn't make sense with what you were saying.
So first thing you have to do is look at the denominator, identify the conjugate. So that's the part you have to know how to figure out a conjugate. And then we're going to multiply top and bottom by the conjugate. Okay, so here's a easier one to start. Real number in the top, complex number in the bottom. All right, so to divide it, we're going to multiply top and bottom by the conjugate of the denominator. What's the conjugate of the denominator? 3 minus 4i. And it's all distributive. But what's nice about this one is all you have to do is distribute a 1. You know, if it was a 2, you distribute the 2. Whatever's here, you distribute it to whatever's here. Okay? So what do I get in the top? Yeah. I get 1 times 3, right? Minus 1 times 4i. We're just multiplying the top by 1. Nothing changes. Any question why the top stayed the same this time? Okay, the only time it would ever stay the same is if you multiply by 1. Okay. What's the bottom come out to? 25. Good. That's where using that shortcut comes in. Multiply conjugates. Square the 3, 9. Square the 4, 16. 9 plus 16, 25. Okay, so the last part is you need to write it, real part and imaginary part, separate. This is the real part. 3/25. Okay. This is the imaginary part. -4/25. Okay, the way I did that is I just took each number in the top and divided it by what's in the bottom. It's like having a common denominator. They both have a denominator of 25. That's how you'll see the answers on the test. Not like what's up above, like what I circled. Any question on that? Right, let's try one more with division. This time it's a complex number in the top and a complex number in the bottom. We still do the same steps. Except now you're going to have to use FOIL in the top. Who can tell me what I'm going to multiply top and bottom by here? 5 plus 12i? How'd you get that? What is 5 plus 12i? Exactly. It's the conjugate of the bottom. Some people try to do the conjugate of the top. Don't do that. Conjugate of the bottom. Okay, the bottom should be pretty quick to multiply. Okay. What are the two numbers I'm going to add together when I distribute out what's in the bottom? 20. Yep, 25 and 144. Okay, we do need to add those up in the next step. Okay, now unfortunately in the top, there is no quick way to do it. You just distribute it out, see what you get. Chelsea, what's 1 times 5?
5.
You have 5. Okay, Brittany, 1 times 12i. You get 12i. Holly, 5 times 4i. So we have a 12i plus a 20i. 12 and 20 is 32. Okay, last part is 4i times 12i. What is it?
48 I squared.
Okay, so you can do 4 times 12 is 48, and then I times I is I squared. Okay, we'll just leave it like that for now. So we have positive 48i squared. All right, there's a lot of little arithmetic things we need to do here. Jen, can you tell me one thing I could do here?
You could add 25 and 44.
Yeah, we got to add these up. Okay, so the denominator is 169. How about in the numerator?
Negative 40.
Yeah, I got to change this I squared to negative 1 and multiply it by 48. Okay, so almost there. 5 take away 48, combine those together. How about Danielle?
Negative 43.
Yep, negative 43. Plus 32i all over 169. Is it okay to leave the final answer like that? No, we got to split it. 2 fractions. What's my first fraction? JC?
Negative 43 over 169.
Good. Second fraction?
32i over 169.
Yep, 32. And what I'm going to do,
Put the I right there.
yeah, I'm just going to put the I right on the side of the fraction. You could keep it in the top, that's okay. But that's where we normally put it. Okay, any questions on division? Okay, it's not too bad. You just follow the process, combine like terms, and split it up at the end. But once we learn how to do that in polar, I can make every step here go away. Not have to do any of that. And we can do it in our head. The disadvantage is you need to understand polar, okay, with complex numbers. Right? So we've done polar, we've done complex numbers, and now we're going to kind of combine the two ideas together. Complex numbers in polar. All right, first thing we'll look at in 5.3, it's called the complex plane. This is kind of a separate little thing. It's basically how you graph a complex number, and it's pretty easy. Okay, on the complex plane, instead of having an x and a y-axis, you have a real axis that's horizontal, and the imaginary axis that's vertical. So if I wanted to graph the point 2 plus 3i, I look at the real part, it's 2. Look at the imaginary part, it's 3. This is just like graphing the point 2 comma 3. Go 2 on the real axis, 3 on the imaginary. That's it. That's the point 2 plus 3i. Okay. Just make sure you don't mix up which axis is real and which axis is imaginary. On the test, they'll be labeled just like that, R and I. So it's going to be labeled for you, so you shouldn't mix it up. Any question on that? How about 4 minus 8i? You can tell me how I would graph that. Just kind of give me directions from the origin. Which way would I go?
4 to the right,
Yep, I'm going to go 4 to the right,
and down 8.
and then down 8. That's it. How about negative 8? Where some people start to get confused now because there's no imaginary part. Yeah, it's just 8 to the left. Since there's no imaginary part, you're not going up or down. Here's negative 8. And Helene, how about 5i?
It would be like 5 up.
5 up, perfect. Okay, so that's the complex plane. Really very, very, very similar to graphing coordinates. Any question on that? Okay. All right, so last thing. Okay, we're going to start this and we'll finish this tomorrow. All right, so we're going to look at how do we take a complex number that's in rectangular form, okay, which is what you guys have been using all along, and change it to polar. Okay, when we did complex numbers in the last section, I think I used A and B. I'm going to switch over to X and Y now because we're thinking about graphing. And I think X, people will associate that more with a horizontal, or left and right. And Y, people usually think of that as the vertical, up and down. I could still use A and B, but I think X and Y will make more sense for graphing. Okay, so here's our complex number, X plus IY. Again, we normally put the I after. Like you wouldn't say I2, you'd say 2I. But technically it's okay if you put the I before it, and in this section they do. You'll see why in a second. Okay, this is the rectangular form of a complex number. It's what you guys have been doing all along. It's what we just did on the last page. It tells you left and right, and then up and down. Okay, you're moving on a rectangular or a square grid. So now we want to get that point, or that complex number, in polar. What are the two letters that we use in polar? Okay, we don't use X and Y. We use an R and we use a theta. So our goal is we're going to get rid of the X and the Y, and we're going to turn it into an R and a theta. We had two formulas earlier in the week for doing that. We already know how to change X to R and theta and Y. Does anyone remember the formula for X? R cosine theta. Yep. We went through the proof and the explanation of that, so we don't have to go through that again. We just need to remember what they are. How about somebody else? What was Y? Yeah? R sine theta. Okay. All you're going to do is take X, and you're going to change X to what that says right there. X is R cosine theta. You're going to take Y, and you're going to change Y to what that says right there. R sine theta. So you're going to substitute in those two things in the boxes for those two boxes up above. Okay, and when you do that, we're going to get R cosine theta plus, we have I, that stays right where it is, times Y. Y equals R sine theta. What's a common factor in the first term and the second term? Theta is an argument to the trig function. So it's what the trig function is multiplied by. R. R is a common factor in each term. So when we have something that's in common, we can take it out. Put it on the outside. What would I be left with if I factor R out from the first term? Yep, just cosine theta. Okay, Rosa, what would I be left with if I factor R out from the second term?
I sine theta.
I sine theta. And that's the polar form of a complex number. R, parentheses, cosine theta, plus I sine theta. Polar form makes multiplication, division, and raising to a power something you can almost do in your head. You don't have to do any of that foiling. You're not going to have to worry about I squareds and changing it to negative ones and combining like terms and conjugates and any of that stuff. We'll be able to do this in our head. Okay, I'm not going to show you how to do arithmetic yet like this. We'll practice finding R and theta today, and then that'll be it. So we have to figure out r and we have to figure out theta. We already have formulas for doing that. We did that yesterday. Theta was inverse tangent of y over x. Okay, so I'm not going to rewrite the formula because you already have it. And to find r, it's r squared equals x squared plus y squared. You use the exact same formulas you already know to do this. Nothing new. The only thing you want to be careful is what quadrants do you have to add 180? If your angle is in quadrants 2 or 3, you have to add 180. How would you know if it's in 2 or 3? Graph the point. Look at the quadrant it ends up in. Okay, that's why we practice this graphing. All right, so let's try writing this number in polar. Okay, so it's the square root of 3 minus I. Now, they didn't put a number in front of I. I want to put the number in so I know what it is.
1.
It's 1, or in this case, negative 1. Okay, that'll help me think in my head how to graph it. Okay, I don't know what the square root of 3 is. It's a decimal. But I know it's positive. So on my real axis, I'm positive. On the imaginary axis, negative. Which quadrant am I in? 4. Positive, negative. Somewhere in quadrant 4. When I do inverse tangent of y over x, do I add 180 in quadrant 4? No. Okay, so we need our y value, or in this case, the up and down. What was my movement up and down here? I went down 1. That's like my y, down 1. What's my x, or my horizontal? Square root of 3.
Why did we use I on the top?
You don't use the I, you just use the numbers. Because we're solving for an angle, and an angle is just a number, and an angle is not imaginary. The angle is a real number. All right, so when you're doing your inverse tangent, it's just the number in front of I over the number that's in front. Any other question on that? Okay, so let's see what that comes out to. Okay, make sure you're in degrees. Okay, we'll do it in degrees. So inverse tangent of negative 1 divided by square root of 3. That's negative 30. Okay, so there's my angle. And last step is to find my radius. Okay, take x, which is the square root of 3. Square it. Take your y, or your vertical, it's negative 1. Square it. Add those two together, and then we'll take the square root. JC, what's the square root of 3 squared? 3. Okay, Jimmy, what's negative 1 squared?
Positive 1.
Positive 1. Okay, so add them up. 3 plus 1 gives me 4. What's my radius here? 2. Yep, square root it. Get 2. Okay, now write your final answer. Just take this, take that, and fill it into that. R cosine theta plus I sine theta. Once you fill it in, you're done. You don't do anything else. So it's R cosine theta plus I sine theta. Don't do that out. Okay. If you were to find the cosine of negative 30 and multiply it by 2, you'd be changing it back to what we started with. Same thing if you took the sine of negative 30 and distributed the 2 to it, You'd be changing that back to what you started with. So that's the polar form. The only thing they might do is they might write it with a positive angle. What can you add to an angle that doesn't change where it lands, but it makes it bigger? You could add 360. So what you could do is you could write it instead of as a negative, positive 330. I think that looks a little cleaner because then you don't have that negative in there. Okay, or if you got stuck and you didn't know how to do that on the test, you could always take what you have and you could change it to a decimal. And if I had a multiple choice answer, you could plug in my answers, change them to decimals, and see what matches according to the decimal. But I would try to understand the idea of just adding 360. It's simple enough.
Would they add 360
What's that?
for you? At times, would they add 360 for you?
Well, sometimes you won't have to. If the angle doesn't come out negative, you don't even need to think about that. In this case, it just came out negative. Okay, so any question on that? All right, so just to be clear, you don't have to prove where this formula comes from. Okay, we went through the kind of the explanation right here. All you have to do is know the formula. That's it. Know how you get R, know how you get theta from yesterday's notes. Okay? And tomorrow we get about 25 minutes in this lesson to finish up, so we'll do that tomorrow. So on 560, I want you to try 15 to 27 odd and 28. Okay, that's multiplying and dividing in rectangular. And then page 333, 11 to 19 odd. Okay, and there's 2 steps for 11 to 19. Part 1, graphics. Bless you. Step 2, write it in polar. Okay, so for each problem, 11 to 19, they want you to graph it just like we did at the beginning, and then change it to polar, just like our last problem.